Good morning, everyone. Today we are going over chapter 4, which is about the air pressure and air density within our atmosphere. Now, some of you may have gone on an airplane ride sometime in your life, or maybe driven from here to Duluth. And as soon as you drop in over the hill in Duluth and go down into the downtown area, your ears pop. The reason that our ears pop or feel a little bit clogged and then clear after a while is because our body is adjusting to the differences in air pressure. The air density, or number of actual air molecules in a given volume, decreases with increasing altitude. This is why people who climb tall mountains, such as Mount Everest, have to set up camp at different elevations to let their bodies get used to the decreased air density. Why, do you suppose, does air density increase or decrease, with altitude? It's because gravity actually pulls the air molecules down to the ground, right? Air has mass. Air is stuff. It's not just this invisible, it is invisible matter, but it is matter, right? There's stuff there. And because the Earth has so much gravity, it's pulling all of those little air molecules closer down to the ground. So as we're standing here on the ground, we've got the air pressure, which is going to be the highest. And as we move away from the ground, our air pressure will decrease and decrease and decrease and decrease all the way up through the atmosphere until we reach space. Okay? Gases at sea level are also compressed by the weight of the atmosphere above them. The force of the air weighing down over a unit area is known as atmospheric pressure or air pressure. So why then are we not crushed by the atmosphere weighing down on our shoulders? Well, because our bodies are designed to compensate. We kind of push back at that air pressure so we don't collapse. And air pressure is felt from all directions on us, not just from above. But you have to kind of think of, and I think the video at the end of this chapter also says this, but if you had a big tube, okay, a big tube that is big enough around to fit eggs in, stacking eggs one after the other in a big tube, which egg is going to feel the most pressure? Which egg is going to have the most weight on top of it? And that's the one on the bottom. So you got to think of us as the egg on the bottom, and then stacked on top of us is all of the air in the whole atmosphere. And so again, air pressure is the greatest down at the ground, and it's actually the greatest at sea level. If you go somewhere that is actually at sea level, like New Orleans, it's going to have really, really high air pressure. At higher altitudes, the atmospheric pressure is lower and the air is less dense than at lower altitudes. That's what makes your ears pop when you change altitude. Gas molecules are found inside your ears. When you change altitude quickly, like when an airplane is descending, your inner ear keeps the density of molecules at the original altitude, and that's why we feel that kind of popping sensation. Eventually, the air molecules inside your body suddenly move through this small tube in your ear, and those equalizes the pressure, and our ears will pop and clear. Okay, we've got a short little video here, and you have got 6 questions to go along with chapter 4 on your Atmosphere iBook Google Doc. And tomorrow we will go over chapter 5, which is about temperature in the atmosphere and how that changes with altitude. Okay, I'll talk to you soon.